Okay, good morning all. So today my plan is to go to chapter 4, and but before we start chapter 4, let's do or discuss something that related to chapter 3 first. So maybe you have some question. If you want to ask, you may ask also before we proceed to chapter 3. Chapter 4. All right. So let's look at this first before we proceed to chapter 4. This is not pop quiz, just kidding. Actually, I want to discuss this example. This is interesting also to practice what you have learned from chapter 3. Okay. Done already, attendant? So that we can start with this. Okay. So this is still chapter 3, where we have one interesting problem here, where we want to find value in memory, for example, from this address 2000 0100 to 200001FF, and return when we found the value that we want to find within this memory location. We then return the address of that value into R3. We have a memory location. Okay, so this is our memory. So we have starting from address 20000100, and the next one is 2000010102 until the last address that we want to look at is 200001F. Okay, so we want to find a specific unique value, for example, number 5. Okay, and let's assume that in this memory range, only one number 5 in this memory means that number 5 is unique. For example, number 5 is here, 5, and the address of this number 5 is 20000110, for example. So our program will search one by one in the memory location from here to the next one, until it found our value number 5, and it will return the address, this address 2000110 into R3. So this is our idea. So we have memory location from this address to this address. So we want to find a number. So for example, number 5, and return that the address of that number 5 into R3 register. Okay. So now we want to write the program for this. Okay. So how to write the program? Remember, we need to start with flowchart. Okay. We need to plan our program, and the best planning is by using a flowchart. Okay. So let's go the flowchart. Right, you may have your point to the first address. Okay, we use R0 to point to, so R0 will point to this address, the first one. And maybe we have the last address. So we can use R1, or in this case I use R4, point to the last address. Okay, so we have R0 to point to the first address and R4 to point to the last address. Now we set our desired value, okay, the value that we want to find. Maybe we can use R2. Okay, desired, put our the value in R2, right? And then what to do next? We have our desired value in R2. Okay, so let's say this is our R2. So our desired value is maybe, in this case, we want to find number 5. So we can get this number, this value, okay, into one of the temporary register, maybe in R1. So we move the value from the first address to R1. For example, the value is 1, and then we compare with what is inside R2. If found, then we return this address to, in this case, R3. Right? If not, we need to check for the second location. If not found, we go to the third, and so on. All right. So here we can say that we get the value from what is pointed by to R1, right? What is pointed by R0 to R1, and then we compare with, and before we compare, we update R0 first, right? Because next we want to move, check in the next location. So we need to update R0 by 1. So this is how we update R0 by 1. R0 plus 1. Okay, so that if we not found number 5 here, we will go to the next one. Okay, and after we get the value to R1 already, then we compare with the desired value in R2. So we can use the decision box for comparison. Okay, so we test whether R2 is equal to R1 or not. Right? So if yes, if equal, means that we found the value already. All right? Means that we found the value already. So if we found, what to do? So we just copy or return the address to R3, and the process is done. Done or end. But if not found, if no, what to do? If no, we need to check the second location here. All right. So we need to go back and check. But before we go back, we need to check whether the next location is the end address or not. Right? If the end address already, we need to finish our job. So we need to check. Second check here whether we reach the end address already. End address already. If end address already means that we are reaching this address already. So if we reach that address already, we need to finish our search. But if not finished yet, so we need to go back and get the value into R1 again and again until we find the number. So this should be our flowchart. All right, any question? Okay, Fatih asks, Fatih Yakan, yeah, not understand the end address. Okay. Any other question? But you understand the problem, yeah? Okay. So I answer Fatih question. Okay. So again, this is our full flowchart, right? So what we want to do is from this memory location, all right? From this memory location to this memory location, we want to find a number and return the address of that number into R3. So for example, our desired number is in this location. All right. So our program will search one location by one location, starting from this address. If not find, go to the next one until okay, found our desired number here. So then it will copy the address of this number into R3 and finish the job. Okay. So if not find any number, so it will search until here and finish. All right, and return nothing to R3. Okay, and for this example, let's assume that the number that we want to find is unique. All right, means that only one number in this memory location. Okay, so this is the flowchart of our program. So we start with R0 will hold this value. R0 will point to the first address of our memory, R0, and R4 will point to the end address of in the memory. All right, this is end address. Okay, so and the desired value is in R2. Okay, the desired value we want to find. For example, in this case is 5. That we put in R2. Okay, now the process of searching here. This is the process of searching. Right, first we get the value, the first value to R1. All right, so the first value is here and pointed by R0. That's why this is the square bracket here, meaning that the content of memory address pointed by R0. Yeah, so the content should be the value inside this one. Okay, now we move to R1. We copy the first value to to R1. All right, move to R1, and then what do we do here? We update R0 so that the R0 now point to the next address here. Okay, this one. And later we compare with the value that we read from the memory, compare with our desired value, which is R in R2. So here we compare, all right, whether the value in R2, the desired value, and the value from the memory is the same or not, equal or not. All right. If equal means that we found already. Okay. So if found already, we just return the address of that number into R3 and our job is done here. But if not found, we need to go back, all right, to look in the next address. So, but before we go back, we need to check also whether we have reached the end address already or not, all right? Because if we have reached the end address, we need to stop our search, okay? So this we check whether we are at the end address already or not. Means that we check the value of R0 equal to R4 or not, right? Because our pointer is in R0 and the end address is in R4. So we check that value. If equal, so we finish the job. Not found. But if not equal, means that we are in somewhere before the end address. So we need to go back and search again. All right. So go back and get the next value into R1 and update R0 and compare again until we found the desired value. All right, Pati, is it clear? For other, if you have for others, if you have a question, you can ask also. Okay, Pati say okay. So if you clear on that, so we will do write our program. All right. Bong in the chat now. Bong asks, can we use post index in updating? Yes, correct. Post index. We can use post index. All right. I will show after this in the program. Okay, so we proceed to the program. All right, so let's write our program. If you have your computer now, you can start to write your program also. Yeah, we can do this together. All right. So maybe you join the class using your phone, so that you can use your laptop or computer to write the program. Okay, let's write the program according to our flowchart. So if we have our flowchart, yeah, writing a program is straightforward. So remember, okay, in exam or in whatever project you want to do after this, if you have your specification, your problem, so plan your solution first. All right. So the best solution planning for programming is flowchart. All right. Flowchart is like the algorithm. All right. Or maybe you can have what is so-called pseudocode. Okay, can be used also. All right. But in microcontroller, the best way is to use the flowchart. Yeah. Okay. So let's start with the this. So we have the main we want to point R0 to the first address. So what is the instruction to be used? Of course, the LPR, or you may also use move. But of course, if you use move, you need to move 2 times because the address is 32-bit, right? So you need to move W and move T. But if you use LDR, you can use only one instruction. Okay? So this is the way how we load the address into a register. The address is 200001100. Okay, and the end address will be in R4, right? Based on our program in R4. Is 0000 1 FF. Okay. So, but according to this flowchart, because we update R0 already here, means that when we reach the last address, our last address here will add with 1, so it will be 200 instead of 1 FF, right? So instead of comparing with 1 FF, so the correct one is actually 200. Because our last address here, R0 is now 1 FF plus 1. Alright, so we compare with 200 actually. Okay, so that is this one and this one. Alright, 2 box, 2 instruction. The next one is load the desired value in R2. So this is easy. Just use the move instruction. So MOV, we can use MOVW or MOV R2. So the desired instruction must be the immediate value. So the value is, in our case, is 5. In our case, is 5. All right, now in R2 already. Next, we want to do this. Yeah, get the value from the memory to R1. So this here, we need to use what? We need to use load. Yeah, when you want to move value or data from memory to register, so you need to use load. All right. So in our case, the data is byte size, so we use LPRB pointed by to R1, right? So we can, this is R1 pointed by R0, and next we update R0. Later, for Bong Yong Kang suggestion, post index later on, I just show what we can do with this flowchart. All right. So after we load, we update R0 plus 1, so ADDS R0 with 1. All right. So this can be used also according to our flowchart. But the best way is actually we can use only one instruction, just like as suggested by Bong. We can use post index, where after we load the data from the memory to R1 here, we can update the pointer immediately after we load, using the same instruction. So that is the post index addressing mode, right? By doing this, right? So if we have this, So no need this, because arc0 will be updated automatically after we load from the memory. All right. Okay. So if we have post index, no need to update R0 already after this, because update is implicitly in this instruction. Okay. Now we have this already. Now we want to do this. We compare, right? We compare R2 with R1. So what is the instruction to be used? Of course, the compare instruction. So the compare is CMP. Compare what? You can compare R1 to R2 or R2 to R1. Doesn't matter. R2, the desired value or desired value is in R2. Compare R2 with R1. All right. So if equal, all right. If equal, what do we do? If equal, we do this. Return the address to R3. All right. So if equal, so what is it? What is the instruction? If equal, we do this. Okay. So we have BEQ, branch if equal, or branch if not equal, BNE. Right? In this case, we use BEQ, branch if equal. Means that if the content of this register and this register if is equal, so we branch. All right? We jump to this location. So maybe the label is found. So means that if equal, we branch to found. So our found is over here, found. So if found already, what do? We do this. Return the address to R3. So the address, how to return the address to R3? Just move what is inside R0 to R3, right? Because the address is in R0. But remember, R0, the address of the data is actually updated to the address plus 1. Yeah. So let's go back to it here. All right. Remember, R0, for example, we found our 5 here, right? Our 5 here, and okay, here R0 we set we transfer the value of this 5 to R1, but later on our R0 is actually going to the next address already because of this. Right? All right. So in our program, instead of move what is in R0 to R3, we need to deduct or deduct value of R0 by 1 to get back to the correct address, right? Because the value in R0 is updated by the address of that value plus 1. So before we move, we need to stop R0 with 1 first. All right. If not, it will give you the next address of that value, not the correct address. And then it will be done here. Okay. Now, if not found, this is the case when we found. But if not found, this way. If not found, so must be here. All right. So if not found, we need to compare with the end address. Yeah. So just compare. So CMP. Compare. Compare what? Compare R0 with R4. Okay. If equal, so we can just BQ again. If equal, means that we reach the last address already, the end address already. So we just go to done maybe the label, and our done is here. Done, do nothing, and all right. So here also after finish, go to done. Here after finish, go to done. So it should be okay here. And here we should, after we check here, we should go back to this level, right? So go back. So we can use B branch unconditional to this label. So this label maybe we made it again. Then okay. Right. Okay. So this should be the program. Exactly based on the project. Okay, any question on the program before we simulate this program? All right, so let's check our program. All right, let's say our number 5 is in the first location. Yeah, easier to check. Number 5 in the first location. So let's see. So we have this 5 in R2, and then we move R0 to R1. So R0 now point to R pointed by R0. So number 5 now is in R1. So compare this 5 compare 5. Okay, equal. So found. Go to this R0 minus by 1 because R0 is add with 1 here. So we have 2 0 0 0 0 1 0 1 minus 1, which is 2 0 0 0 0 1 0 0, and we move to R3. Yes, we found. All right, but if not, we need to compare with R0 with R4 and address. If not the same, we go back. Yeah, go back. But if the same, we finish. Go to done. Right. So this program should work. Okay. Now let's see in the simulation. All right, where we do the debug. Okay. So this is debug. So this is our program, and this is memory location. So let's see the number that we want is 5, right? So let's see, number 5 is, maybe we put somewhere very near to this. Oh, here. Okay. Number 5. So this is the number that we want to see. So in R3 we should have this address, right? 2000010. Okay, because our desired number is here. Any other memory location, we don't care. All right, can be any number. Okay, so we try to run to. Okay, so is there a problem with our program? Let's run one by one. Yeah. So it looks like it's run in the endless loop. All right, let's check one by one. All right, so how to check one by one? So we can use this debug. Yeah. So let's reset again, and the value is 1FF already. Let's change the value 0, and our value is in here. Here. Okay. So let's start from here. Run. Okay. Okay. Oh, not yet. Okay. 208 already. So means that our program, okay, means that our program is not go to this found, all right? R1, R2. R1 is in R2. Oh, we don't have R2. Inside R2, we should have 5, right? What a problem here. Okay, this is a good debugging lesson. All right. So let's say our program now is not we cannot get the correct result. All right. So let's check together. So now it seems like in R2 we don't have 5. All right. Here in R2 we don't have 5. Okay. We should have 5 in R2. So let's start again, one by one. Okay, so we start from here, loading this value to R0 and see. All right, so we have, and this should be in R4. So we have, this should be in 5 in R2. We don't have. Okay, it seems like we don't have 5 in R2. Okay, this is quite weird. Any idea? Again. All right, so let's see. 1, 2, 6 in R1. We don't have 5 in R2. Why? So let's go back to the program. And R2. Okay, this is weird. So let's change to R5 and see what happens. Okay, there's one error. Oh, actually, the program is not correct, right? We have error in our program. Yes, we have error in our program. Done. Yes, syntax error. This done is not the same. Oh, okay. So it should be DONE. As a reminder, yeah, the kill, this label here is case sensitive, yeah, meaning that if you use uppercase here and here is lowercase like this, so this is not the same, all right? So it will not refer to the same label. So we need to have, all right, the same one. Okay, so this should be done. All right, no error, no warning. Should be good. Okay, let's go back. All right, so we have number 5 in here again, and let's run the program. All right, so we have the answer here now. In R3 is we have the result now. 2000103 is our number 5. Is it correct? Let's see. This is memory location 100 here, 2000 100 here, 101 102 103. Yes, 20000 103. So this is our the location, and our program inserts from this, and done. You see the red font here, right? So let's change the location. So this is number 0, and our number 5 is here. Okay, number 5 is here, and let's run again. You need to reset. and 1 with this one. Okay, so we have this is the result. Is it correct? 12D, right? 20 million 12D. So let's see. Yes, this is the address. Okay. So if our number 5 is out of range, for example, not in this range, where is the range? So the last one should be after 200, right? So number 5 is here, for example. So it will test, reset, one again. Okay. So return nothing to R3, yeah, because out of range already. All right, out of range already. Okay, so that is the solution for this. So if you not understand, you may ask now, or maybe you can refer back to this video. So I will upload this video on YouTube. Okay, or you can ask me personally through Edmodo or WhatsApp. All right, any question? So this will be a good example for practicing the what we have learned in chapter 3. Yeah. So what we have do here, we have compare, we have addressing mode. Yeah. Post index addressing. We compare and we branch, means that we use the program control. Okay. And also we indirectly we learn how to debug our program just now. All right, unexpected. All right, any question before we go to chapter 4? Okay, and I have posted the tutorial, the step-by-step explanation tutorial for number 5 for chapter 3. For number 6, I plan to do so, but I think the concept is similar to number 5, so you can try to do on your own first. Maybe later, if we have time, we can discuss. And for the last exercise, what is the number? Rearrange the hello words to backward. All right. So I plan to give to ask you to do an assignment for that, yeah, individual assignment. Okay. Is there any question? Atau still tidur lagi? Okay. All right. Good. Okay. So before we go to chapter 4, yeah. Tell me a little bit about your condition, whether you are staying at home or still in university. For example, you don't want to go back, kan? Tak nak balik, sayang universiti. Tak balik, Stay at home, okay. Stay at home and stay safe, Alright, our university tak tahu bila nak buka lagi. Alright. But at home your internet is okay, So ada lagi yang kat university. Internet so-so. But still can follow the class. Alright, using the lowest possible resolution code. But But if you use lowest resolution, maybe the sharpness of the screen, the program tu susah sikit nak dapat kan. Maybe if but later I will upload the video on YouTube. So kalau you ada internet, you go to, tapi you tak boleh keluar kan? You mana tahu kat luar rumah ke, right? You download the content and boleh tengok balik lah. Okay. Alright, so hope you all okay ya, semua sihat. Tak ada yang kena quarantine ya. Tapi quarantine pun boleh tengok video. We are online. Okay, so hopefully our country will be closer to normal, walaupun new normal kan. Alright, so now let's go to chapter 4 right ya. Oh, ada satu question rasanya saya. Wait. I think I spot one. Ahmad Hadri asked, assignment contribute how many percent? Let's open the mark distribution dulu. Let me check the marks distribution for this class. Okay, so quiz kita dah buat kan? Quiz 5%, test belum buat lagi, 15%. Test pun kita akan buat online this month lah, hopefully we can settle with the test. Project asal ialah 30%, but because of this final exam mungkin kita reduce jadi 40%. So jadi assignment akan jadi project. So project of course you will not able to do your project kan, because you bukan dalam group now, and also you have limited resources, tak ada hardware, so you tak boleh buat lah project. So recommended by the faculty is project change to simulation project kan. Tapi simulation pun tak sesuai juga untuk our case kan. I mean simulation for project lah, because that hardware you need to have the microcontroller kalau tidak ni. Actually nanti dalam chapter 4 I will show you the online simulator for this, but that one also can simulate very limited I/O lah. Not all things you can simulate. For example, if you have a motor, you cannot simulate. You can simulate only the PWM saja. Alright, so project cannot be done using simulation lah. So we will change to individual assignment, and assignment ada banyak lah, macam last time I give you one assignment already, and then second one mungkin yang soalan tutorial tu. Markah project last time we plan is 30 marks ya. So sekarang assignment akan jadi 40 lah. 40 plus dengan quiz dengan test dia akan jadi 60. Alright, and then the final examination will be around 40, so total 100 lah. Okay. Okay, Ahmad, Adri, okay ya. Right. So now we go to chapter 4. Okay, Raihan tanya, quiz one time only, nak banyak kali ke? Tak nak nak banyak kali boleh juga. Oh, Fatih boleh lah, dia skor 5/5. Dia tak nak lah. we will see the situation lah macam mana we will see the situation. Kalau perlu saya akan bagilah. Alright. Okay, so pergi cepat ni, nanti habis banyak data pula you kan. Alright, so I go to chapter 4. Okay. So this is chapter 4. We have 6 chapters, yeah. So 4 already, and we are in week 8. So I think should be we should be able to finish all the chapter. No problem. All right. And sometimes I will post the video for explaining some of the parts yang agak susah kot. Macam yesterday I post the solution for tutorial macam itulah, so that you can learn at your own time, at your pace. All right. So chapter 4 is about the microcontroller. Right. Last time what we learned is most of the time is microprocessor, what is inside the microprocessor circuit, the architecture, and the instruction set architecture, and how to program the microprocessor. Right. So for chapter 4, we will go to the specific architecture, specific device, right? Which is the microcontroller. And the microcontroller that we will use is the LPC1768. So this microcontroller is actually based on ARM architecture. All right, and as you know, ARM architecture is the most popular architecture in the world. Yeah, so 90+% of the microprocessor and microcontroller in the world is based on ARM architecture. Yeah, even your handphone is using ARM architecture. All right, but that one is the A profile. We have how many profile? We have 3 profile, right? We have A, we have R, we have M. Yeah. So in your handphone is A profile, the microprocessor, ARM microprocessor profile. This one LPC1768 ni ialah M profile, microcontroller profile. And it is manufactured by NXP. Yeah? NXP is formerly known as Philips. Yeah? Philips. So as we have discussed in the in chapter 1, that ARM the license the design to other manufacturers. So for example, Samsung, right, want to fabricate the microprocessor chip using the ARM architecture. So Samsung will buy the IP, the architecture daripada ARM and fabricate the microprocessor. All right, but the core inside is ARM architecture, same as this LPC1768. All right, so Philips will get the IP from the ARM and then fabricate this microcontroller and name it LPC1768. All right, so the ARM core inside here is actually ARM Cortex M3. Okay, so meaning that the instruction set is exactly the same with what we have learned in chapter 3, right? So what we have what we will learn in this chapter, we will look at the of course the introduction to LPC1768, and then what we will see next is the memory map I/O. What is memory map I/O? The ARM embed, which is the open source platform that we will use in writing our program, compiling our program, right? We will look at digital input output, right? Before this, we're not looking at the I/O yet, yeah, because the microprocessor is what inside your PC or your handphone, yeah, right? So we just look at how to move the data between the register and also the data between the microprocessor, the CPU, and the memory. Now we will look how to connect to the outside, the I/O. All right. We will see also analog input and output. All right. So because microcontroller normally we use to for specific application, and normally we want to the name is microcontroller, means that we want to use this technology to control something. All right. And to control something, we need input from outside. So the input, all right, you always see the terms what the world is analog, man. So everything we see is actually analog. All right. So before we can put that analog value, analog signal into the microcontroller or microprocessor, so you need to change to digital dulu, because the microprocessor or microcontroller is digital electronic circuit or device. Okay, so we can see analog input and output, yeah, how to input analog into the microprocessor. And next we will look at what we call power-based modulation or PWM. Okay, so this signal is quite important, in, especially in motor control ataupun tidak control many things lah. And we will learn some of the advanced programming technique later on at the end of the chapter. So most of this chapter will be programmed in C programming language. Last time in chapter 3, we learned how to write the program in assembly. Okay. What is the difference between C and assembly? We will see. Okay. So I think this one you can read on your own. Okay. One thing I want to highlight is that why we learn instruction set ataupun assembly language yang susah tadi tu kan, kita buat even find one number in the memory location pun not that easy, right? So why we need to learn assembly language? Why not using high-level language C++ or C or Java or Python or any other high-level language? Because some of the specific tasks actually cannot be done by high-level language, especially the program part ataupun application yang that we need very efficient, very optimized in terms of speed, in terms of space, because assembly language, the size of the assembly language is very compact, very small as compared to C language, right? And the speed very fast as compared to the high-level language. High-level language is actually designed for programmer. So actually, high-level language, when you compile, it will be translated to assembly language as well. Okay, to the specific architecture. So for example, you write C on your computer using the Intel microprocessor, so the compiler will compile or translate that C to the Intel assembly language. For our case, we write our program in C, the compiler will translate our C language to the ARM assembly language that we have learned in chapter 3. Okay. So by learning assembly language, you have the opportunity to learn the architecture, because when you learn assembly language, you will understand the architecture, right? You know what is inside the microprocessor. So for example, if you want to be a microprocessor designer, you want to design a microprocessor. So first thing you need to know is the architecture, and the best way to learn architecture is by learning assembly language, right? Or you want to write a device firmware, okay? So you need to know assembly language as well, or you want to write the library, for example. Okay, so that is the importance of assembly language. But assembly language, if you want to develop a very fast prototype application, and macam like controlling the temperature inside our room, temperature monitoring, IoT application. So that application assembly language is not suitable because assembly language is very time consuming. All right. So for that kind of application, so you can use C language, such that you can use the open source library, and so that you can integrate with your project and to have your project very fast. Okay. So in chapter 4, we will look at that site pula. All right. Right. Hope you're clear on that. Okay. So before we start with the programming and so on, of course, we need to look a little bit about the architecture. What is exactly the microcontroller? This microcontroller LPC1768. So this is the block diagram of this microcontroller, and again, this is simplified diagram. Yeah, the actual one is more complicated than this. So here we can see this is Cortex-M3 core. So this is the CPU, the core of the microcontroller, sorry, right? So the memory, not memory, the register that we learn R0 to R15 in programming model tu ada kat dalam ni lah, inside this Cortex-M3 core, alright? So the assembly language that we learn also is running inside here. All right. So here is the memory connected using this bus, and you will have other peripheral as well. All right. In microprocessor, you don't have everything here. You only have this. All right. Microprocessor, but microcontroller, you have everything. Every peripheral, for example, the ADC, the PWM, the timer, the serial communication, the CAN interface, USB interface inside your IC, your chip, your single chip. Everything is inside single chip. So that is microcontroller. And of course, the processor size here is smaller as compared to the microprocessor in your handphone. All right. But you have everything inside that chip. All right. The microprocessor in your handphone is only this part. Okay. So let's go to the next. Here is setting. This is the full name of this thing. All right. Next is the memory map I/O. So what is that memory map I/O? So remember that last time in ARM architecture, we have microprocessor, and we have the memory part. And the memory part in the ARM microprocessor. So what is the memory space or memory size that we can have in our ARM Cortex-M4? Anyone can give the answer. Very fast one. No answer. All right. So our ARM Cortex-M3, the size of the address bus is 32-bit, right? 32-bit. So if you use your calculator, 2 power of 32, you will have 4 gigabyte. All right. So that is the memory space yang you can use in this ARM Cortex-M3. But that 4 gigabyte is actually very big, very huge, very big. So actually ARM, all right, or any other microprocessor or microcontroller, they have divided that memory memory spaces to many different parts. So, for example, in this case, the LPC1768, this is the memory location that we have, 4 GB, starting from this address 0 until the address 4 gig. Okay, so it's divided into many parts. For example, here, this part from this location, address 0 to address 80,000. All right, this is 51K kilobyte. Is dedicated for on-chip flash. Means that this is the on-chip memory for storing your program. So when you're writing your program, assembly language, C language, it will be stored here in this memory location. And from this address to this address, this is reserved. Means that you cannot use reserved. All right. And from this address to this address, it is used for RAM. Sini pula reserves. And this is for ROM. This is for this, and GPIO is here. GPIO is general purpose input output. So from this address to this address. All right. We will look in detail later on. Yeah. So don't worry, no need to memorize this. In the exam online, you can open anytime. Right. So you need to understand this, not to memorize this. So you will see that many parts of the memory is reserved. Reserved means that actually for that 4 GB space, you don't use all the space actually. Okay, so some parts only. So this we call memory map. What is memory map I/O? Is actually we access the I/O input output through the memory space. All right, means that the I/O is actually part of the memory space. For example, GPIO. That's it. All right. So from this address to this address, this is reserved for GPIO, meaning that if you have your I/O, you want to connect your microcontroller to LCD display, for example. So you need to connect to your LCD using this address, one of these address. We will see later what is the specific address. All right. You have the keyboard or switches or LED, so you need to use this range of address. All right. So that the microcontroller know, oh, this address is my input, this address is my output. Okay. And what is this? This is actually this part, because this part is, there are many things inside. This is for peripheral, right? APB is advanced peripheral bus 0. So this from 4002 to 4008, 40000, 4008000. So there are many things inside. For example, ADC, the serial communication. So we will learn later on part of this. Part of this. And also for peripheral number 1, the second one, this is the peripheral that is connected to the this memory address. And because this is microcontroller, everything is inside this one single chip, means that this is fixed. All right, this is fixed. Okay, any question? All right, if no, we will go to the next one. Now, how the GPIO, the input output, is represented in the memory. Okay, so this is how the GPIO is called port in microcontroller. All right, port. So for ARM Cortex M3, we have 5 ports. We have port 0, port 1, port 2, port 3, and port 4. All right, we have 5 ports. All right. And each port we have how many bits in size? 32 bit. All right. So 32 bit. Bit number 0 until bit number 31. 32 bit. Okay. And if you look at this, you notice that there are two colors. So here the blue one is the bit, the bit that you can use, and the gray one is the bit that you cannot use or it is not available. What is meant by not available? Not available here means that this one is not connected to the outside. Here is connected to the outside. What is meant by connected to outside? Connected but to the outside means connect to the I/O pin. All right. So you see that port 0 we have many bits that are connected to the outside. Bit port 1 also many. Port 2 not many, only 0 to 13. Port 3 only 2 bits that are available, 25, 26. Port 4 also 2 bits. All right. For this microcontroller, any other microcontroller may be different, right? Now the next question is, where exactly is the port, right? So the port is actually inside this GPIO. So let me explain where is the location of the port. Yeah. So I will change this to. Okay, I'll bring this to here. Okay, so we have our port here. This is port 0, yeah, and the size is 8 bit. So the organization is like this. So the ARM microcontroller object entry is divides the port into 4 bytes. Yeah, so we have 4 bytes, right? So the first byte will be in this part. We call this byte 0. All right. For bit number 0 to bit 7, we call byte 0. From bit 15 to bit 8, we call byte 1. From 23 to 16, we call byte 2. And 31 to 24, we call byte 3. Okay. So one port, we have 4 bytes. And 1 byte will occupy 1 memory location. So in this case, for example, this is just example, and we will see the exact location after this. Okay. So let's, for example, and this is our memory. So the GPIO starting at address 0 2009 C000, right? C000. The next one will be 2009 C001, 2009 C002, 2009 C003, and so on. Okay. So this actually byte 0 is for this one, byte 1 for this one, byte 2 for this one, and byte 3 for this one. All right. And the next address will be the port number 1, and so on. All right. So it organized like that in the memory. Okay. Hope you're clear on that. Is it clear? How the port is, or where the port is located in the memory? Hopefully you clear on that before we proceed. Okay, good. Izul say yes. So Izul will represent all the rest, yeah? We have 77 people here. Yeah. All right. So now we know already the relation between the port and the location in the memory. Now, what is the exact address for this? How do we know the exact address for byte 0 of port 0, for example, byte 1 of port 0, and other port 1, port 2, port 3, right? So we have 5 ports. So how to know that? So to know that, you need to have this. Okay, I stop this presenting so that I can show you this. Okay. All right. So you need to have this menu, user menu. Okay. So you can download, go to the internet and download, or maybe I share on Edmodo. All right. So this manual is how many pages here? 851 pages. All right. Quite huge, yeah. But this is the job of engineer, right? We not memorize the things, but we use the manual, yeah, to solve our problem. So where is the port now? All right, how to use this manual to find our port. All right. So let's go back to the. Hey, did you see the manual? Oh, I haven't presented. Okay, I present. Sorry, yeah. Okay, can you see the manual now? Okay, so this is the manual. 851 pages. All right. Everything is inside here. NXP. This including many series of microcontroller. So in our case, is this one, LPC1768. But why the port? How to get the address of the port? So again, we need to go back to this by port. So we need to know what is the name of this one. All right. So the LPC1768 name this, for example, byte 0. Byte 0 of port 0 as FIO 0 means port 0. PIN 0. Okay. FIO 0 means port 0. Port 0. PIN 0 means byte 0. Byte 0. So this thing will be explained later in the notes, but I think better explain here. Easier to understand. All right. So the LPC 1768 name this byte, this byte of port 0, byte 0 of port 0 as FIO 0 PIN 0. Port 0, byte 0. For byte 1, the name is FIO, still port 0. So this is 0. I use this symbol because if I use O like this, you will confuse. This is O, this is 0. FIO 0, byte 1 is PIN 1. Byte 2, FIO0 PIN2 and so on. All right. If for port 1, so port 1 by 0 will be, if for port 1 by 0 will be FIO1, means port 1 by 0 is PIN0. Okay, hope you're clear on that. All right. So now, how to look the or find the port address in the manual? So you can let's go back to the manual. Yeah, let's go back to the manual. So there are 851 pages to go through, right? So that is not possible one by one, or you can find in chapter by chapter here. But the best way is to use the find feature. All right. So for example, we want to look at port 1. Okay. So the name is FIO port 0, yeah. FIO 0 PIN 0 or byte 0. Okay. So at page on page 138. All right. So this is the address. So the address, the actual address is actually 2009C014. So this is the address for the port 0 byte 0. What about byte 1? All right. Where is byte 1? So this is not byte 1. This is FIO1 PIN0, means that this is port 1 by 0. Here is, yes, where are we? Yeah, sorry. So this is byte 1, FIO 0 PIN1. This is byte 1, C15, C015. You see the next address, just the next address of this one, 1415. The next is byte 1. The next is byte 2, 16. And the next one is byte 3, 17. Okay, same as port 1. So port 1, this is port 1, FIO1 PIN0. This is byte 0, 34. Here the address is 34. We can expect, we can guess already for byte 1, right? Which is 35, right? 35. 36 is byte 2, and 37 is byte 3, and so on. So this is the address, all right? So if you want to see, want to get the address, go to the manual and search for that port, that particular port. Okay, hope you're clear on this. We will use this later. Okay. Now let's imagine this. We want to have a very simple application, right? We want to have a very simple application where we have our microcontroller. This is our microcontroller, the LPC1768. Microcontroller, the LPC1768. And we want to connect this microcontroller to the outside, to one of very simple output device. We can use the LED, for example. Okay. And we want to have this microcontroller and LED. We want to have this LED blink every 1 second or every 0.5 second or whatever, but we want to have this LED to blink, right? So how, the question is how to write the program to do this. Okay. Can you do that? All right. So first thing is that we need to connect this LED to the microcontroller pin here. Pin. And this pin must be connected to the I/O port, right? So let's, for example, this pin is connect to connect to this, right? This pin is connected to this, our I/O port, bit number 0 of byte 0. All right. So I draw. Okay. So this is byte. We just name it FIO 0, PIN 0, which is port 0, byte 0, right? So we have 8 bit inside this. Zero, 1, 2, 3, 4, 5, 6, 7. Okay, so this LED, right? This LED connect to bit 0. Okay, connect to bit 0, meaning that if we have 1 here, logic 1 here, it will on the LED, right? It will on the LED. Okay, logic 1 will give, in our case, will give you output. Oops, sorry. Will give you logic high or 3.3 volt here. Okay, so it will turn on the LED. All right, and when you want to off the LED, you just have 0 inside this bit. All right, and it will off the LED. So the idea is you set this bit to 1 to on, make it 0 to off, on off, 1 0 1 0 1 0. Then this LED will blink. Okay, but the question is how to do that. All right. So because we know that this is in this address, right? In the memory space 2009 C014, means that if we send byte value 00000001 here, it will on the LED, right? So you can use str, right? Instruction strb. Okay, and when we want to off, you send 0 to this location, and you will have on 0, and this will off the LED, right? Okay, hope you're clear on that first before we go further. Okay, all right, I want to know your feedback. Are you clear on that? You know, it is hard for me to whether to know whether you get the concept or not. In the face-to-face class, I can see your face. Yeah? I can know whether you are in the what ready to absorb the concept or not. Yeah? But online, I cannot see it. So, all right, you get the concept, yeah? Relate what we have learned last time to this, and now we use or we apply what we have learned in chapter 1 to 3 in practical or the real world application now, right? Okay, so this is the idea. But the problem is now, this port, this port is actually bidirectional port. What is mean by that bidirectional port? Bidirectional port means this port can be input or output depending on setting. All right, means that we need to tell the microcontroller that this particular bit or all the bit in this port is output or otherwise. Okay, so we need to tell the microcontroller first that this is the output. Then the microcontroller know, yeah, when we put value inside this this register, one will be on the LED. Okay, provided that we tell the microcontroller already that this bit is output. All right. If not, the microcontroller will do nothing. All right, because it doesn't know this is input or output. All right. So how to do that? So to do that, you need another register. We call it data direction register. This is actually a location in the memory also. Yeah. Direction register, data direction register. So for byte 0, port 0, the data direction register that control this port, this port is named FIO 0 DIR 0. All right. So this port or this memory location will control whether this one, or will tell the microcontroller whether this one is this one is input or output. So for this FIO 0 DR 0 also 8-bit in size. So it has 8-bit number 0, 1, 2, 3, 4, 5, 6, 7 as well. So bit number 0 will tell the microcontroller whether bit number 0 of this port is input or output. Bit number 1 will control bit number 1, 2 will control bit number 2, and so on until bit number 7. Okay. So what is the information that we need? So for this ARM microcontroller, one inside this bit means this one is output. If you have 0 inside here, for example, bit number 1 is 0, means that this one is input. If you have 1, means output. If you have 0, means input. Okay, I hope you're clear on that before we proceed. This is very important concept. All right, if not clear, let me know so that I can explain again. All right, if not, I will proceed. Again, yeah, Fatih say again. Okay. Fatih, the IO port concept you understood, eh? You get the concept? Okay. So you just not understand the oh, this is Hani, not Fatih. Fatih. Oh, Fatih say yes. Also yes. Okay, good. So again, go back. I need to have a new space. Okay. So for example, this is our byte 0, port 0. The name is FIO 0 EIN 0. Correct? And our LED is connected to this bit number 0. The others we don't care. Okay, and this one, the address in the memory is 2009C00 C014, right? Okay, so this we clear already. So when we have one inside this, because this one is connected to the pin, and this pin is connected to LED, right? So if one here will on this LED, if we put 0 here, it will off the LED, right? So that is the idea. Now, before we do that, because the microcontroller doesn't know whether this is input or output, all right? Although if the microprocessor don't know whether this is input or output, bit number 0 here, if the microprocessor don't know whether this is input or output, but if you put 1 in here before you tell the microprocessor that this is output, when you run the program, you will get nothing. All right, the LED will not turn on because the microcontroller will not know this is output. All right, so you need to tell the microcontroller this is the output first before you can put 1 inside this bit. Okay, so how to do that? So you need another register, another memory location called the control data register, or the name is FIO DIR. In this case, FIO 0 DIR 0. Okay. So the data inside this register will determine whether this one is input or output, and it is very specific. All right. So if we want to tell the microcontroller that bit number 0 of this port, by 0 port 0, this bit, to be an output, so we need to put 1 inside this, okay, bit number 0 of this register. Okay, but if we put 0, if we have 0, meaning that this bit is input. All right, means that this is wrong. All right, we want to connect this bit to the LED, So if we set this to input, this is wrong because LED is output. Okay, so if we put 0, means that this one is input, so it is wrong. All right, so we will get nothing. Okay, so we need to tell the correct setting. So the correct setting is to set this as an output. So how to set as an output? Put 1. All right. So for the data direction register, FIO DIR, data direction register. All right. 0 means input. 1 means output. That's it. So for example, you want to connect the second. You want to connect the second bit. All right. Let's say you have bit number 1 here. You want to connect to the switch. All right. You want to connect to the switch. Means that this one should be input. All right, should be input. So if we want to set this bit to be an input, so we need to put 0 in. Yeah. Okay. So now the microcontroller know that this one is input. Because why? Because we connect to the switch. And we put one here. This one tells the microcontroller that this is output. Because we connect this to the LED. All right. I hope you're clear on that. Fatih? All right. Good. Okay. So if we clear on that, we want to proceed to example maybe. Yeah. Okay. So let's go back to the exam. So we are here. So we have port 0, port 1, port 2, port 3, and port 4. So the setting is actually the same, only the name is different. Oh, one more thing is that where is the address for FIO 0, DIR 0? So again, you need to go to the manual. Let's look at the manual. So where is it? In our case is FIO DIR 0, right? So DIR 0. Here. Okay. So the address for actually the first address of the IO GPIO is the FIO 0 DIR 0. So the address of the control register is here. 2009 C000. This is for port 0. For port 1, for byte 1, this is for byte 0, byte 1, C001, byte 2, byte 3, and so on. Okay. So we will go back to this later when we look at the example. So let's go back to the slide. Okay. Now this one is the same thing that I have explained just now. Same thing for the name. So just skip this. This is another example. So for example, this is FIO 0, DIR 0. Yeah. By number 0 of port 0, right? So 8-bit, bit number 0 to bit number 7. So let's see, for example, in bit number 4 to bit number 7, if we put 0, 0, 0, 0 here, meaning that all bit in this port, FIO 0, PIN 0, will be an input. All right. If you have 1, 1, 1, 1 here, so we will set all this to be an output. Right. So that is the way, and this is the address. The address for this is the address for this. Okay. And this is the pin description of the microcontroller, the LPC1768. All right. Now, where is the connection? All right. So let's look at the. If you're not clear on this, you can open the lecture note. All right. Because maybe from the internet, the diagram is not that clear, so you cannot see the text here. So maybe you can use your lecture note. So for example, let's go to this. For the easier example, now this one may be easy. DIP 26. This pin. The name is DIP 26. Pin number 75. And look at what inside here. P2.0. What is meant by P2.0? P2.0 is actually meaning that this pin, this very pin, is connected to port 2, bit number 0. The next one, the IP2574, pin 74. This pin is connected to port 2, bit number 1. All right. So port 2, bit 0, for example. So where is port 2, bit 0? Okay, this is port 2, bit 0. Means that pin, this pin, pin 75 or the IP26, all right, the IP26 is connected to this, okay. So when we have want to do the same application as the previous example just now. So for example, we want to connect this to LED, all right. If we want to connect this to LED, we need that to turn on LED, we need to put 1 in this. 1 here means on the LED. 0 here means off the LED. Okay? As simple as that. Alright? Now, let's look at the example. Right? Before we write the program in C language, we are still in assembly language, yeah? So that you can look at the difference between the two. All right, when we shift from assembly language to the C language. Okay, so let's look at this application. This is a simple application to blink, just to blink the LED. Okay, so let's see. In this case, example, blinking the LED connected to pin DIP21. Where is DIP21? This one. Yeah. DIP21, this one. So look here. This is P2.5. P2.5 means it is connected to bit, port 2, bit number 5. Port 2, bit number 5. Yeah. Port 2, bit number 5. Yeah. Right? So what is the name of port 2, bit number 5? The name must be FIO2 PIN 0. Alright, because bit number 5 is located in byte 0. Okay, remember that. Okay, port 2, bit 5. So the port name is FIO2. FIO2 means port 2, PIN 0. PIN 0 because byte 0. Bit number 5 is located in byte 0. Okay. And we equate and use EQU. EQU is equate, means that we assign this value to this, and this value is the address of FIO2 pin 0. So where is it? We need to open the manual, right? So the manual is here. FIO2 PIN 0. The address is 2009 C05 C054. All right, that's why we equate this value to this, so that later on we can use this as our in our program. All right, and this is the port. So remember, you need to have your direction control, data direction control register. So what is that? Must be FIO2 DIR0, right? 2200. And where is the address? So the address is here. FIO2 DIR0 is 2009 C040. Okay, 40. Right? Clear on that? Okay, if you clear, so we go to the whiteboard. I want to explain this a little bit. Okay. Go back to whiteboard. Right? Now, we have our okay. So this is the what 2 by 0. Okay. So the name must be FIO 0, well, not 0 now, it will be 2 EIN 0, and the address is 9000 C not 900 2009 C 0 5 4, right? And this is 8-bit. This is 8-bit. So we have bit number 0, bit number 1, number 2, number 3, number 5, 4, 5, 6, 7, and bit number 5 is connected or will be connected to the LED. So this exact bit we connect to the LED. Okay, so means that if we want to on the LED, we need to set this to 1. If we want to off the LED, we will need to clear this bit to 0. Okay, but before that, we need to have to tell the microcontroller that this is the output, right? So you need another register. Okay, the name is FIO2 DIR 0, and the address is 2009 C0 040. Okay, and this you also have 8-bit. Here you have bit number 0, 1, 2, 3, 4, 5, 6, 7 here. And to tell the microcontroller that this bit is output, so you need to have 1. You need to have 1 inside here. Okay, now the microcontroller know that this 1 is output. So whenever you put 1 here, then the LED will off. When you put 0, the LED will on. Right? Okay, clear? So we go back to the slide. Okay. So now we have this. Okay. So now R0, yeah, is load with this address, right? So R0 now point to this location, right? In this case, R0 is pointed point to this location. All right, means that R0 anything that we send to by R0 will go to this address. Okay, and this one, the FIO2 PAN0 is pointed by R1. All right, so now R0 is the direction register, R1 is the port. Okay, now let's see this. Now what we want to do, what we do here, we put FF All right, move FF into R2. Okay, FF into R2, and this FF is 8-bit into R2, and we send strb, store byte. We send what is inside R2, which is FF, right, to what is pointed by R0. The address is that is pointed by R0, which is this DIR, direction register. So meaning that when we execute this instruction, we will have what? We will have this inside FIODIR, right? FF means that 1 1 1 1 1 1 1. Right? Automatically we will set this bit to 1 by moving FF into this register. Right? Meaning that we tell the microcontroller that this bit in this port is output. All right, that is the case. Okay, this one. So we set, yeah, bit number 5 to be an output. Now look at this. Now we move to 0, hexadecimal to 0 to R2, and from R2 we send to what is pointed by R1. So R1 pointed to this location. All right, 20. What is 20? 20 in hexadecimal. 20. If we change to binary, we will have 0 0 1 0 for 2 and 0. Right? 8-bit. So this is for 0, this is for 2. Okay, and we send to where? We send to here. Okay, meaning that when we execute that instruction, here we'll have 0 0 1 0 0 0 0 0. What does that mean? Means we turn on this LED on when we execute this instruction. When we execute this instruction, right? We will turn on the LED, and because we want to blink, all right. Next, we need to turn off, right? So how to turn off? We send 0 to the same location. So send 0. This is send 0 to the same location. But before we send 0, we need to do this because the microcontroller or microprocessor is running very fast. All right. If you immediately send this on and off immediately, all right, because the microcontroller will execute this all instruction in less than in microsecond, you know. So if in microsecond you actually cannot see the blink, you will see the LED will always turn on, all right, because it will run very fast. Okay, so what you need to do is you need to have this. You slow down the microcontroller. So how to slow down? You do this. This is subroutine, right? BL is called subroutine. You have a subroutine named delay, means that you jump to this delay routine so that the microcontroller will do something else to waste time here. So that you can see that, oh, here, your LED is on, wait, off, and you go back, on, wait, off, wait, go back. Okay, so that is the way. So the delay routine here, you see, I move a big number, a big value into R3 and reduce that value by 1 until it becomes 0. All right, so it will waste some time here. All right, before go back to off. Okay, so this value is quite big, yeah, 10 million. But this is actually very fast. I will show you later. All right, because your microcontroller is connected to the clock, and the clock is very fast. In this case, I don't remember how many megahertz, right? But megahertz, and even gigahertz some microcontroller, right? So that is why we need to have this. Okay. So this is the program to on, right? 10 to 0. Why to 0? Because to 0 is 0, 0, 1, 0, and 1 that is in bit 5, all right, on the LED, and then send 0 to the output. We have the off, the LED off. Okay. All right. Now, any question? All right. So that is the concept. You see, want to on the LED is not that easy. Using assembly language. That's why if you want to have the complete or more advanced application, IoT application or temperature control application, or analog process the data using assembly languages, you can do that, but very difficult and very time consuming. That's why later on we will use C programming instead. Any questions so far? So this is the concept I want you to okay, come say no, come says no. Good. All right, I think that's I go back to present the screen. Okay. So let's go back to the program. So this is the program to bring the LED, and this program explain or demonstrate how to use the this connected to which pin and which port in our microprocessor, and how to write the program. So if you want to use other port, you can refer to this, and also you need to refer to the manual, right? And it's also explain how you want to set to do the setup, which bit you want to set as an input, which bit you want to set as an output, right? And how many ports. So all right. So don't be scared of this course just yet, because later on we will look at the easier way to do the things, right? So this is the explanation or the knowledge that I want you to know, so that you appreciate what you will learn later on. All right. So by learning this, you know how the things are going on inside, how the microprocessor works, how the microcontroller works, and relate to the architecture, and relate to the assembly language instruction set that we have learned in chapter 1 to 3. Okay, so later we will use the library, meaning that instead of using or doing this the hard way here, we will have a more easier way to tell the microprocessor that this is my input, this is my output. All right. So that we will use what we call the embed. So embed is actually an API. What is called API. API is application programming interface. meaning that it will sit between your hardware, your microcontroller, and your program. Just now, you communicate directly with your hardware. That's why it is very, not very, but quite hard to write a program. But now you will have the interface between you and your microcontroller, and you will use this library or application programming interface to communicate with your microcontroller, and the process is much more easier. All right. So I will stop the lecture today here because we are in 11:30 now, almost 3 hours already. So I hope that you get the concept today, and next week we will come back to learn this. And actually, your project, we plan your project to use this embed. All right. So for my section, actually, I explained this already in our second class, and I show you already how to use this actually. All right. So the embed, we will use another compiler that is online, available online, and this is free. All right, but you need internet connection to use that compiler. Means that you can write the program later on using your web browser and compile using your web browser, and you can download to the microcontroller chip. But again, because of this COVID-19 MCO, so you don't have access to the microcontroller, right? But don't worry, luckily we have the online compiler, so I can show you here. If you can see, can you see the my browser? All right, you can go to embed simulator on your browser, and you can choose this one. The best way is this one, embed simulator. Right. So this is the simulator where you can have a virtual microcontroller like this, and you can write your program here, and you can add your component. For example, you want to have LED, you want to have push button switch, potentiometer, PWM speaker, the temperature and humidity sensor, the LCD, the touchscreen LCD, and so on. You can have this option. All right. So maybe our assignment later on for chapter 4, 5, 6 will be using this one for simulation, and also your examination maybe. Okay. So this program is very simple to bring this LED. Yeah? You can see the program is simple, and you can see the LED is blinking here. All right. So I think today should be enough already. Right? Cannot be too much. If not, you cannot grab it. Right? So any question before we end our session? Okay, so if no, we end our session here. Thank you very much, and selamat berpuasa for the Muslims. Thank you very much.